Good day. We're going to look at this electrolysis PowerPoint in a series of videos. Reminder, electrolysis, we're talking about lysis, that means to split. So we're breaking down ionic compounds using electricity. Electrolysis, we need to have a soluble ionic compound. We need to have an electrolyte. And we talked about electrolytes last year in grade 11. That's where I had that light bulb and it would light up or not depending on whether we had free ions. So, negative ions attracted to the anode. So, anions go to the anode and cations go to the cathode. And remember the oil rig, if that helps you. So here we have, in this case, that's an indicator of a cell or a battery providing the electricity to make reactions happen. And we have to get used to symbols. If it's a little L, molten, it means we don't have to worry about water, it's been melted. If it's an electrolyte that's been dissolved, then it has AQ, dissolved in water. So we have to get in the habit of looking at things and figuring out, hey, what reaction are we going to get? So here we have zinc chloride, we have graphite, which are carbon inert electrodes, and we see heat, so that's why this is molten. We don't have to worry about water. And the zinc is going to reduce, and the chloride is going to oxidize to chlorine gas, a nice poisonous gas. But when we have aqueous solutions, we have to worry about the possibility of water reacting and generating things like hydrogen, oxygen gas. So here it says if we have molten PbBr, well, that means all we have present are the lead and the bromine. It should have a 2 there. And so here's the bromide being oxidized, and here are the lead ions being reduced. But if we have a solution of KBr, now we have K plus, Br minus, but we also have water. And so we're going to have to worry about, in this case, well, the bromide still will be able to be oxidized, but instead we're going to have the water. And that water is what we're going to have to worry about being reduced. So we look at this, brine, just a nice salt solution, sodium chloride or seawater. And it talks about the salt water coming in, and here's our chlorine that we got from it. And at the other electrode we're getting hydrogen because we cannot take out the sodium. Sodium is it has such a tendency to oxidize and such a low tendency to reduce. So sodium chloride, we get sodium and chloride ions, and water, until a tiny amount, gives us H plus and OH minus. So we look at all these ions present, and then we say, hey, what's going to happen? How are these things going to move? And what's going to react? So in this case, we have the chloride, they're reacting to make chlorine. And the water is going to supply the OH minus, and away we go. And there's the hydrogen. If sodium's present, it's the hydrogen that's going to reduce first. So first we look at the migration. And those, well, once those are gone, then the other materials might be able to react. So it talks about hydrogen and chlorine, sodium hydroxide being produced. And here are the reactions. So here's electrolyzing brine. And again, it's talking about what happens at electrodes and what's ending up in solution, essentially unreacted. So the next video will start here. That's the electrolysis of copper to sulfate using inert electrodes.